So as all of you are since from computer science, as it was mentioned in the morning, what is the importance of security? All of you are aware it. Okay. So the main importance for the cyber security for the current days and for the future is proliferation of digital devices, digital transactions, networked communication. All those are all leading to the point that we have to secure our communications, transactions, messages, all that. But how do we do that? How do we do the security of all these transactions? The backbone for all the security is the cryptography. Okay. So is the cryptography is something new that has started with the digital transactions and communications? Certainly not, right? So cryptography has a very old history, okay? Starting from ancient civilizations, it has its own history. So in these cryptography sessions, what are all the topics that we cover is, number one, we deal with the classical ciphers. Okay. We also provide some fundamentals of the cryptography, right? There are certain fundamentals that one should be aware in learning the cryptographic algorithms. I think some of you might have already learned the data encryption standard, DES, advanced encryption standard, AES. Okay. So we all learn in the today's session, tomorrow and the day after. Number one, again, we revisit these algorithms and also we understand the backbone of these algorithms. What are the topics that are backbone to these algorithms? And subsequently, we will be having the hands-on sessions in the afternoon, wherein which you will be implementing these algorithms through any of the programming language, right? So we proceed towards the cryptography. First of all, if you want to know what is the term cryptography means, so a dictionary defines cryptography like this. It is about, number one, secret writing. Okay. I want to communicate something, I want to send a message, I want to make a transaction. How I do it? Secretly. Why? What is meant by secretly doing it? Number one, it is that no other person who is not the authorized person or authorized, only authorized people will be having access or will be able to read it. No other persons will be able to read it. So that is one of the major purpose of having the secret writing, which we call it the terms called confidentiality and integrity. Have you heard it? Confidentiality and integrity? Fine. So the another definition is enciphering and deciphering. Is there any difference between encryption and ciphering? What is the meaning? What is the word says? Enciphering and deciphering of the messages in secret code. So we also learn what is meant by enciphering and deciphering. Okay. Also we learn about what is encryption and decryption. Okay. So these are the technical the definitions that are available in the dictionary. Okay. And other than that, there are various other definitions, but the definition what we will be discussing in the lectures is from the book Modern Cryptography, Applied Mathematics for Encryption and Information Security by Storm. So what the definition from that book says, cryptography is the study of how to alter a message so that someone intercepting it. What is meant by interception? Interference, and then coming in between. So interception means somebody listening to this communication. Okay. Are they interrupting? No, they are not interrupting. They are only intercepting. There is a difference between interception and interruption. So we are talking about interception. The reason is, if there is an interruption, it is easy to detect. But interception is difficult to detect. Do we know that who is listening to our conversation? Anybody who is listening to the conversation beyond this particular room? Do we know? How do we know? Right? It is very difficult until and unless we go out and check, right? So interception is difficult to detect. Interruption is easy to detect. So what we are talking here is that about interception. So how to alter a message so that someone intercepting it cannot read it. That means what? We are by default assuming that there is somebody who will be always intercepting, because what we are conversing in the communication channel, which is an internet, right? Internet is a open communication network, right? It's not a organization network, right? Like a local area network, which is a secured network, whereas internet is a open network. So open network means anybody would be listening to the conversation. So what is the aim? Cryptography is the study of how to alter a message, whatever the message I want to communicate, how do I alter it so that whoever is intercepting it cannot read it. They cannot read it. But if at all somebody wants to read it, what they should have? They should have appropriate algorithm and key. So only those people who has the access to number one, algorithm, number two, key, they only will be able to understand what is the message I am sending. Okay, that is the purpose of cryptography. So again, we repeat, it is that I have to send a message to someone. What I do for that purpose? I am going to alter the message. I am not going to send the message as it is what I wanted to send. What I wanted to send is the plain message. When I alter it, how it becomes? Since you have already undergone the course, when I alter it, how do I call it? Ciphertext. So I alter the message, my plain text message, and hence it becomes ciphertext. Okay. How do I do it from message to ciphertext? With the help of an algorithm. That algorithm I call it as encryption algorithm, right? In order to do that, what I need a key. Okay. So only those people who have access to number one, algorithm, and number two, key, will be able to decrypt it. Others cannot. So that is the purpose of the cryptography. If we have it, then that is fine. We will be able to secure our communications. So as I said, is it that word cryptography, or is it that techniques of cryptography is something new? Certainly not. It is coming from very old ancient civilizations. So cryptography, the word comes from the Greek word kryptos. What is the meaning of kryptos? The meaning is hidden and graphene, and it is hidden to write. And when you look at this hidden writing, it has very long history from early civilizations onwards, including in Egypt, even as well as in India. You can see the roots of secret writing. Okay, you can see the roots of secret writing. Now, when it comes to the techniques per se, okay, when it comes to techniques per se, the point why we are talking about the technique is what is required. What is that we are required to make secret writing as per the definition? Number one, algorithm. Number two, key. We will see the key part later. What is meant by algorithm? A step-by-step procedure to do something. So let us talk about, when you look at the history, what are all the techniques that are there, so that you can create an algorithm for that. Okay. So if you look at them, in 100 BC, you have Julius Caesar, which was prominent encryption or a technique called Caesar cipher. In fact, he used a form of encryption so that he can send the secret messages, okay, to his people in the war. That we call it as the Caesar cipher. Okay, that we will be discussing it in the next slides. Then subsequently, after Caesar, there were so many other approaches, techniques, but in 16th century, we have a cipher called Vigneri cipher. Okay. So these are all, we people call them as the classical ciphers. And during First World War, we have, machines, both electrical as well as mechanical machines. So during that time, we have a cipher called rotating machines, right? Rotor machines. Okay. So they were the ones who were subsequently modified to form the machine called Enigma. Just now the registrar madam was mentioning about the Enigma machine, right? Which was used in the World War II. Have you seen the film where, what was the film? Imitation Game, right? So, which was, based on the Alan Turing's work in breaking the Enigma machine, right? So, we have rotating machines which were used to create the ciphers, right? And again, so let us see how they work. So this is a very quick history, and those who are really interested to learn about the history of cryptography, there are very excellent resources both online and as well as in the books. So I would suggest you to have a quick look at the history of cryptography and all that. Now, before we proceed, let us understand certain terminology, those who are in the second year and trying to learn them. So a typical language, a natural language text, we call it as the plain text, right? Whatever we are interacting now is the plain text. And is it a secret text? No, because it's in the form of a plain messages, right? So this is the original intelligible message, which we call it as the plain text. A sender wants to send it to the receiver. Next, what is the other term that we have? Ciphertext. What is the ciphertext? When you change the plain text to an unintelligible message or non-readable message. When I say non-readable, it doesn't mean that somebody cannot read. Everybody can read it, that particular text. But would they derive any meaning out of it? No. So that is what is meant by unintelligible message. So how do you get it? You get that ciphertext with the help of an algorithm. That's what we saw in the previous slide. And is it only the algorithm? No, you also need a key. So ciphertext is another term. Then there is a next term called encryption. What is meant by encryption? The process of encoding the message. Which message? Plain text to ciphertext. That means which is not an obvious word. Then decryption, which is the reverse process of the encryption, right? So you need to, because why to do the decryption at the receiver side, they have to get back the message. So it is exactly the reverse form of your encryption process. That's the reason why when you see the encryption algorithm, the decryption algorithm would be exactly the reverse of encryption algorithm. When you put both the encryption algorithm and decryption algorithm together, you call that as the crypto system. You call that as a crypto system. Then, what is meant by cryptography? The cryptography are about mathematical techniques related to making of secret codes. Remember, you need to understand, or you need to keep a focus on the term called mathematical techniques, right? Then, what is cryptanalysis? There is one more term which is an important term. Cryptanalysis means it is about breaking of secret codes, right? With cryptography, you make the secret codes. With cryptanalysis, you break them, right? Few seconds back, we talked about decryption. Is decryption and cryptanalysis both are same? Why? What is the difference? What is the difference? Yeah, both are algorithm. Very good. Okay, very good. So that means, imagine somebody who is having the algorithm and key, they have taken the ciphertext and they are getting the plain text. That is the process of decryption, because he has algorithm as well as the key. Most importantly, not the algorithm, it is the key. Who will have the key? Only the authorized person. Okay, the assumption is only authorized person. Imagine that if the key is stolen, then gone. Everything has gone. So that, the decryption process is typically done by the legitimate and authorized persons. A cryptanalysis is done by illegitimate and unauthorized people, because even though they may have the algorithm and key, but they are not authorized, right? So it is about that. So cryptanalysis, that is the reason why we say breaking of secret codes. Decryption is typically decrypting the secret codes, right? What is cryptology? Cryptology is about techniques related to both making and breaking. Cryptography deals with only the cryptography deals with only making. Cryptanalysis deals with only breaking. Cryptology deals with both making and breaking. So that means those who are really serious, want to build their career in the area of the secret algorithms and keys, it is better you focus on to become a cryptologist, because you are the expert to both make and break, right? So cryptologist will do both. Now, there are three more terms which we call encode, encipher and encrypt. Okay, if you notice that the dictionary definition, we used the current term called encipher, right? So let us see what is meant by encoding. It is the process of translating entire word or phrase to a ciphertext. Okay, that is what is called encoding. What is enciphering? Translating letters or symbols individually, that is called enciphering. What is meant by encrypting? When you do both, that means you convert the whole word or alphabet by alphabet. Okay, so just to give you understanding, what is meant by encoding? It says translating the entire word. Let us take one word. See, imagine I have the word called apple. Imagine I have the word called apple, right? This is the plain text. I want to convert it to a ciphertext. For that conversion process, imagine if I take the whole word as such, that is called encoding. That is called encoding. Now, what is meant by enciphering? For the conversion process, I am not taking the whole word, but I am taking alphabet by alphabet. How? I am taking A, then I am taking next P, next I am taking L, next I am taking E. So that means for the algorithm, what is the input when you are doing encoding? Whole word. Whole word is the input to the algorithm. But when you are doing enciphering, what is the input to the algorithm? Only one alphabet. So you finish that alphabet conversion to the ciphertext and go to the next alphabet, and then to the next alphabet. So this is kind called a stream. This is a kind stream. You are going alphabet by alphabet. That's called enciphering. If you give the complete word for conversion process, that is encoding. Now, what we are talking about here? Encryption. What is meant by encryption? Imagine if the algorithm is able to take, both word as well as alphabets, right? It's called encryption. So you need to understand the difference between encoding, enciphering as well as encryption. During the encryption process, what we do? We give input, word as well as the alphabets. Both algorithm accepts both. But if an algorithm accepts only the word, it's called Encoding. If the algorithm process only the alphabets, so are you comfortable with this? So these are the terminologies, right? So how do you do this? You take the message, okay? What is that message you call? This is the plain text, and this is your algorithm, right? This is your algorithm, which you call it as encryption algorithm. What is the other component which is not listed there? Okay, right. So that we will see. So there is a component called key. So encryption algorithm receives your plain text, then key, then subsequently you produce a ciphertext, and at the receiver, which the algorithm you follow is the decryption. The decryption is the which process? The reverse process of, okay, reverse process of encryption. If I don't do reverse process of encryption, what I will get? Again I will get ciphertext, right? Ciphertext, if I don't do in reverse process, what I will get is the ciphertext. So decryption, for that purpose, again what you need? Key you need, right? You need a key, and once you get it, you get a plain text back. So again, so you take the plain text message as P. When you look at the literature, sometimes the plain text is represented as P, sometimes it is represented as M, depending on the algorithm, depending on the book, or depending on the source that you are referring. Okay, right. So imagine if plain text is regarded as the sequence of individual characters, P1, P2, so on, Pn. What you get is the ciphered alphabets, C1, so on to Cm. Okay. So what we are talking here is the crypto system. What is this? P, plain text. What is E? Encryption algorithm. What you get? Ciphertext. So the D stands for decryption, right? So you call this as a crypto system when you call if P is equal to D of E of P. What is E of P? E of P is C. D of C is P. D of C is, so P is equal to D of E of P. What is E of P? C. Because you are doing the encryption over plain text. You get the C. This is happening at, generally it happens at, in a networked communication. C is equal to E of P happens at sender side, because I am the sender, I am sending a message. So what I do, the message P, I encrypt, so I get the ciphertext C. So C is equal to E of P. That happens at the sender side. What happens at the receiver side? What happens at the receiver side? This is how it happens. Take the C, apply the decryption algorithm, you get the plain text. So this P is equal to D of E of P is called crypto system. Right? Are you able to follow? Any doubts? This side. Fine. So as I said, you have a very long history of cryptography. I request you to have a look at this source called History of Cryptography by Farhana Sheikh. Okay, she has listed various developments happening through the ages. Now, when we say this cryptography, what the services that it provides, that means what are the the benefits that the cryptography provides in terms of security. So you remember, security is not a single absolute term, right? Security has many facets. What are the various facets of security? These are the things. Number one, confidentiality. Number one, confidentiality. So what is meant by confidentiality? Huh? Sorry? So when a sender is sending a message to the receiver, only the receiver, that means when I say receiver here, it is the legitimate authorized person should be able to access and read the ciphertext. When I say read the ciphertext, should be able to decrypt it. No unauthorized or illegitimate person will be able to decrypt it. So that's what is confidentiality, right? So the next facet of security is integrity. What is integrity? Imagine there is a transaction. You make an online transaction, right? We say that integrity of the online transaction should be there. What does it mean? No unauthorized, illegitimate parties, users, people should be able to modify the transaction details, right? So that is to preserve the integrity of the message. Then you have another facet of security called authentication. What is authentication? Checking whether it is true. Then, okay, all of us we are wearing the ID cards, right? All of us we are wearing the ID card, one ID card or other form of ID card. So what is the ID card indicates? I am the authenticated user or authenticated employee of this particular institute. Okay. So authentication, that means identifying that particular individual, who he is or who she is, whether they are legitimate people or not. That is authentication. Have you heard the other word called authorization? Authorization. What is authorization? Authorization. What is the difference between authentication and authorization? Please feel free. Yeah, you express.
Authentication is about whether you are who you say you are. Authorization is about whether you are allowed to access whatever you want to access.
Correct. So exactly, it is about I am the authenticated entity or user of this particular resource, whether I am having access to this room or not. Okay. So there is an authentication. Once I have the access, then what type of privileges I am having to operate about the resources in this room, whether I have the privilege to access these almirahs or not, the systems or not. So these are all the privileges, right? Those privileges comes based on my authorization level. Right? Imagine I am the authorized to access all these resources, I'll be able to get. So it is the authorization provides what type of access I will be having. Authentication says whether first of all I am having that privilege or not. Okay. So which comes first? Authentication followed by authorization, right? So there is one more facet of security called non-repudiation. Okay, non-repudiation. The point is that what happens in the communication environments, imagine that there is a transaction between the two parties. Neither of the parties should deny the transaction later, right? Right? Imagine if the sender is sending a message and tomorrow say that, no, I have not sent the message. Or the receiver says, no, I have not received the message. So non-repudiation is another security service or the dimension. So when we say security, I want to have a secured system. What is that is needed? My system should have, what is that it should have? Number 1, confidentiality. Number 2, integrity. Number 3, authentication. Number 4, non-repudiation. Like this, there are various dimensions to the security, and how do I achieve all of them? How do I achieve? I said, yes, my communications or transactions should be secure. When I say secure, communications and transactions should have a confidentiality, communications and transactions should have the integrity, and there should be authentication. How do I do it? So the bottom line of achieving all of them is the cryptography. So the cryptography is the mechanism with which you achieve security services. Is that clear? Are you able to follow? Any doubts so far? Okay, fine. So, what are the various cryptography primitives or techniques that we have? How do I view or learn cryptography? Okay. So, if you want to learn cryptography, cryptography is divided based on these facets. Number one, there is one component we said which is required. What was that? Key, right? So first component is the key. Okay. So how many keys I would be using for my algorithm? That is one dimension of cryptography. Okay. The second dimension of cryptography algorithm is about, there was one thing which we discussed, taking a word and taking alphabet by alphabet, right? Have you remembered that? So that means, how do I organize my plain text? Whether my plain text is organized as words kind of a thing, or alphabets kind of a thing. So for that purpose, my second aspect of the cryptography is about how what? How plain text is arranged. What are the things I said? You said you take some text, go ahead. No, you take what? Alphabet by alphabet. So it is about the way you are organizing your plain text. Have you so far given it to the algorithm? No. We are preparing the input to the algorithm. The way you are preparing to the input to the algorithm is another dimension. So once you have this both, then the third dimension is what? Now, how do I convert my plain text to the ciphertext? That is another dimension. Okay. The technique. Okay. The technique. So these are the three dimensions which you view cryptographic algorithms. So number one, what is the crypto system? How we define? How we defined the crypto system? Yeah. What was the form? P is equal to D of C of E of P. Right? This is what we defined. Now, what is that missing there here is, what is that it is missing? There is a component called key. So, how do I do that is, imagine if my encryption C is equal to E of P comma K. What is K? Key. Right? When I have this, how do I decrypt? How do I decrypt? P is equal to D of C comma P is equal to D of C comma K. Fine? Have you followed this? Now, at both ends of encryption and decryption, what is that variable which is common? K. So that means I am using K at the encryption side, and also I am using the K for decryption side. So the same K. This is called symmetric encryption, because you are having same key for encryption purpose and also the same key for decryption purpose, right? No. I have another scheme called C is equal to E of P comma K1. Okay, and P is equal to D of C comma K2, wherein which K1 is not equal to K2. So what happened now? What happened now? I have used one key for encryption purpose called K1, another key for decryption purpose called K2, where K1 and K2 are not same, right? So this kind of scheme is called as asymmetric because you have used two different keys. Now tell me, we have two schemes. One, we said the sender would use a key for encryption purpose and the receiver would use the same key for decryption purpose. That is called symmetric. Sender would use one key for encryption purpose and the receiver would use another key for decryption purpose. That is a different two keys, and it is called asymmetric encryption because keys are different. Right? Is that clear so far? Now, imagine I am going with symmetric encryption. Imagine I am going with symmetric encryption. I want to send a message, right? So we said, yeah, go for symmetric, right? The reason is, we said there is a sender, there is a receiver. So sender, there is a receiver, right? So sender wants to send the plain text P. What he did? C is equal to E of P comma K and send this. What he is sending? What he is sending? C. And at the receiver, what is that happening is the decryption. P is equal to D of C comma K. Now, this is the scheme, right? This is the scheme. Now, the point is, what is that our basic assumption? What is the basic assumption? There is, this is your, you have, this is the open communication channel, right? So, open network. In an open network, what you will be having always? Somebody who is listening to the communication. There is a bad guy called Eve. Bad guy called Eve. So typically in a literature you will see that this guy is Bob and this person is Alice. Bob is sending a message to Alice and there is somebody listening to conversation Eve, right? This is the scenario. Now Eve will always have C because it's very easy to listen to the open network. Eve will always have C. Now this is the scenario. This is symmetric encryption. What is the advantage and what is the disadvantage? If I do this, what is the advantage and what is the point? Yes. Huh? Huh? It is expensive, inexpensive in terms of computational power. Computational power of what actually? Okay, you mean to say that, okay, his point is that these two algorithms of E and D, okay, this E algorithm and as well as D algorithm, they are computationally less expensive. That's what you say, okay. When you say computationally less expensive in compared with what? Okay, so the other scheme, fine. What are the other thoughts? So the point is that, see, I am worried about sending the message. For that purpose, I have encrypted it. How I encrypted with the help of a key. Now the question is how this key, okay, how K is established or shared between sender and receiver. This is the other challenge, right? No, I am encrypting it. How the receiver, how Bob is encrypting it, how the Alice would decrypt it. And what is the key? how the key would be shared with Alice. That is another challenge. Any other thoughts? Okay. We are talking about in the networked communication, always any cryptography literature, when you read, you will see always Bob is communicating with Alice. Is it that only always Bob and communication happens only between Bob and Alice? Now imagine you have a networked environment of n nodes. Communication happens between any node to the any other node, right? Right? Now the point is, imagine Bob is communicating with 100 nodes. How many keys Bob has to maintain? Because Bob has to maintain with the number of n number of nodes with whom Bob is communicating. Bob has to maintain, because with every node, will he use the same key? He can't use the same key, right? So K cannot be K cannot be repeated with the other nodes in the network, right? How do we manage the keys? Now the point is, we are talking about Bob. What about Alice? Alice also have to. So every node has to, right? Every node has to manage their keys. So key management is the challenge. But as you mentioned, we talk about that the expensive nature of algorithm. In that way, there is an advantage, the encryption and decryption. Fine. So then people said, okay, when symmetric encryption algorithms were introduced, they were all happy. But then you have the challenge. What is that symmetric encryption? Why this symmetric word has come? Because of same key. So when we go back to the slides, there were the 3 dimensions, right? One is the key. So that we are talking about here, right? So symmetric. Then people said, okay, the challenge has come because of the key management has come because how do I share the key? Number 1. Number 2, every node has to maintain the keys that they are using for other nodes. So people said, okay, what if suppose we have an asymmetric scheme wherein which C is equal to E of P comma K1 and P is equal to D of C comma K2, wherein which K1 is not equal to K2. This is called asymmetric scheme. Now, Bob is encrypting the message with the help of K1. Alice is decrypting with the help of, is both are same? No. So you need not worry about sharing that K1 with Alice. You need not worry, right? So in that way, your key management or key distribution problem can be managed. You need not worry about how this, this one. So number 1, mitigate the challenge of key distribution. There's an advantage over symmetric. You have the advantage. Now, what is the challenge because of that? Each receiver has to have the separate key. And any other answers? Yes. See, the point is, result should be the same because you are talking about bringing the P back. I am using one key for encryption purpose. So it is like this. Imagine if you look at the lock of this room, I am using one key for locking purpose and another key for unlocking purpose. Understand? My encryption should allow to use one key for encryption and the decryption should take another key for decryption process. What is decryption? Reverse process. I am using altogether different key. Number one. Okay. So when I am using two different keys, my algorithm should support. So first thing. The second thing is, first of all, how do I generate such keys? How do I generate such keys such that, number one, I use one key for locking and another key for unlocking, but I should not get any kind of errors or loss, right? So what is the challenge here is that, number one, though you have the advantage of mitigating the key distribution, the challenge is that you have key generation. How do you generate the keys? So that is the basic challenge. So we have seen two types of schemes in terms of key. Another one is, and both have their plus and minus. And another thing is that, as you mentioned, expensive or inexpensive, the expensive nature of asymmetric algorithms comes because of this key generation. So asymmetric is expensive. Asymmetric is that expensive because of encryption and decryption? No. It is because key generation. Why? I need to generate the keys in a way that I encrypt with one key and decrypt with. So that is the challenge, right? So this is one dimension of cryptography algorithm. So you take any cryptography algorithm, either that would be a symmetric algorithm or asymmetric algorithm based on number of keys that it uses, right? So the one dimension of security what we discussed is about the key. No sir, I don't have keys. Still you have the algorithms. They are called keyless. Okay. So you have one more scheme wherein which the sender is taking the algorithm called E and getting the ciphertext, and the receiver is using the reverse process just to get the decryption, and you get the plain text. Is there any key here? Is there any key here in the crypto system? So such things are called keyless ciphers. Keyless ciphers. Typically, the hash algorithms are the examples for keyless. Okay. So in terms of cryptography algorithms, the first dimension is in terms of key. Okay, you take any cryptography algorithm, you should ask what is the question, what is this algorithm? Is it a symmetric algorithm or an asymmetric algorithm, or else a keyless cipher? Okay, this is in terms of key. The other dimensions we will see. Maybe we will take a quick break. Okay.